So my name is Hamzah Shanbari, and I am the Director of Innovation at Haskell. Haskell is a design-build firm based out of Jacksonville, Florida. That's where I'm at today. And I specifically work at a different kind of sub-organization called Dysruptek. And at Dysruptek, what we're trying to do is really just be in the forefront of technology and innovation and looking at all these different amazing tools around us in terms of software, in terms of technology that can help us deliver products for our clients. That's ultimately what our goal is to deliver better projects and to enhance the overall well-being of the employees, right? Because people are the most important part of any organization. So part of what we do at Dysruptek is what we focus on is what we call the 3 I's. So invest, invent, and innovate. So we invest time and resources in evaluating all these amazing construction technologies that you see around you in this conference and beyond that, of course. And we also invest some capital in some of these companies when we see that it's fit. And then invent is when we switch hats, is when we have a problem statement that doesn't have a readily off-the-shelf solution to help solve it. And that's when we go to developer mode and actually make things. And this project is part of that invent. And last but not least, we have innovate. And that's our structured innovation program within Haskell that allows all our employee base to submit ideas where we evaluate and select the top ones and act on them. We have 3 patents out of that program and 4 to 5 different products that we're ready to bring to market soon. So going back to invent, reality capture is about to become wiser. That's what we're calling this project. It's called ProjectWise. And as we all know, I mean, I don't even need to preach to the choir over here. You're all at the Reality Capture Network conference. So you understand the importance of reality capture in general. But what I'm trying to focus on for this specific conversation and this specific project is capturing reality in an in-progress construction project. That's a subset of reality capture, right? You're not capturing an entire facility before you design any addition or expansions to it. You're not capturing different elements of existing conditions or a completed project, even like an as-built deliverable. This is all within the content or the context of an in-progress construction project. And we all know the struggle that happens with that. Because we have so many different tools and so many ways other than, I think we finished around 50% off the mechanical scope in the 3rd floor, right? It's a guesstimate. Most of the time it's a guesstimate. Or we're relying on what the trade partner said they completed, right? There has to be some trust there, but also you need to verify at some point. And then what that would do is that drives the entire project's cash flow in terms of payment applications and processing those and approving them. And we all know the current tools that we have access to today that we're going to talk about one by one. So the tools that we have access to today to capture progress in a construction project are your usual suspects. One of them is, of course, photos and videos. These are beautiful things and sometimes really elaborate videos that have sometimes 0 data associated with them, right? In terms of location, in terms of actual progress capture. So we all know that's not going to work. 360 imagery has become something more mainstream these days. And yes, they do work, and especially with the layer of AI on top of that can dissect that 360 video and compare it to the model and actually give you some sort of progress tracking. But capturing that week in and week out in a consistent and constant basis is the challenge. And then last but not least, I know there's a lot of laser scanning geeks out there that are looking at my recording right now. I wish I can see your faces and hear your boos. But laser scanning, as much as I am a big fan of laser scanning, it is a slow and arduous and very complicated process. It takes us so many hours to scan a construction project, and then not to count, registration and putting those point clouds together before you even do anything with them and extract some insights. So yes, these tools do work, but each one of them have a limitation. So let me introduce you to ProjectWise. This is a project that we've been working on for so long. Oh, wait a minute. No, that's a wrong project. Wrong project. All right. ProjectWise. Wi-Fi is here to save the day. And of course, we couldn't find a better picture of John Cena, so this is what we came up with. But the idea here is really nothing crazy or out of the box. I would love to lie to you and tell you I came up with this on my own and I figured it out, but it's not. It's like looking at all these different research projects that are happening, especially in the academic world, and drawing some inspiration out of that. So ProjectWise was actually inspired by a Carnegie Mellon computer science study. They named it DensePose. And what DensePose did is that PhD students put in Wi-Fi transmitters and receivers and were actually very accurately be able to extract the number of humans behind a wall. Not only how many people are behind the wall, but also what poses are they making. And that's kind of what the name comes from, DensePose. So even like whatever pose you're making behind the wall, they can detect that. How insane is that? It's pretty cool. It's kind of like what I'm envisioning is like bat vision strength. So the idea here is like, how do we take this and apply it to a construction project? Not in terms of people and capturing where the people are, because that'd be weird, but in terms of elements, anything that gets installed on a job site. So how does it work? The idea is super simple and very, very similar to what we saw in the Carnegie Mellon paper. You have a Wi-Fi node that one of them transmits and the other one receives. And what you do is you would benchmark that channel state index between the two Wi-Fi nodes. So channel state index is all these different kind of channels and signals that go between Wi-Fi routers. And the idea here is like, if you benchmark what an empty job site looks like, and then you teach an AI model that a duct would disrupt that channel state index in this very specific manner, and it's a little bit slightly different than what a metal pipe would do, then you can start teaching the whole system to recognize all these elements on a job site. Again, sounds fairly simple, but it's all using Wi-Fi routers, for lack of a better term, and kind of like an AI model that analyzes that and then compares what it thinks to the 3D model. You have to have that level of ground truth that you are comparing it to something in order to say, yes, this was actually installed or not. So here's an example. Here's a picture of a job site. Let's say we have installed WISE on this job site. So the WISE system would see that there's a wall there somewhere. So let me see if that wall exists in the 3D model. Yes, it does. All right, that wall was installed, and you just check mark it. I think I see some pipes in this area. All right, let me compare it to the 3D model again and see if there are pipes right there. Yes, those exist. All right, check, check. Those pipes are installed. And the same thing with ducts. So you can see the idea here is like you installed all these different nodes on very specific areas that you have to specify and give it to them, give it to the system, and it would take a look at it. So the idea again is to look at a Wi-Fi signal and augment it with an AI model, and this is where you get WISE. That's our project. And now what we're envisioning with this also is having this web-based platform that actually aggregate all that data from the different nodes. So some of these nodes are going to be, given a transmitter mode, and some of them are going to be a receiver mode. And one of those is going to interpret that data or actually just immediately shoot it up to the cloud via an LTE chip. And the system can be accessed through a web browser where you can see what the progress on your job site looks like. So again, this is still super early on in the research and development mode. We actually applied a patent for this as well, so it is patent pending. That's why I'm able to share it with you all very freely. Otherwise, I would be, required to sign an NDA with each and every one of you, which would not be very efficient now, would it? So we're working with a couple of development firms that helps us kind of evaluate this further. But part of the first level of looking at this, let's call it phase one, is like, is this even feasible? Yes, we saw the Carnegie Mellon study that they were able to detect humans behind walls, but can we detect the wall itself, or a duct, or a pipe, or a conduit, and all these different elements that go into construction projects? So the idea here is fairly simple. We have a receiver node, we have a transmitter node, empty between them, empty space, and we benchmark that. And then we see what happens when you put an object in between them, right? It's going to disrupt the channel state index between the transmitter and the receiver. And we'll see if we can teach an AI model to detect that and actually classify it. So the first model we looked at, and again, this is using supervised learning and creating an AI model. So we have an empty space, we have a large object, a metal object, and then a small object. And we're putting those objects in between the transmitter and receiver, and we're telling the AI model, this is what the object is. And we're doing it over and over and over to teach it, right? So you can see this is what they call a confusion matrix in the AI world, where you want your diagonal that goes from the top left to the bottom right to be as close to 100% as possible. Everything else is noise, is wrong, right? So the more we teach it, the more it's going to understand. But teaching it is one thing, and putting it in action is a completely other thing. So let's take a look at what the first model did when we removed the teaching aspect and said, all right, here's an object in between you two. What is it? So as you can see, it's starting to detect some of those elements. Very good accuracy, kind of like when you're talking about a large object or a metal object, but not so much when it's empty and small object, because it's confusing the two, right? So we continued to iterate on that and teach the model even more. So we created a second model that we fed it so much more data and spent so much time and effort in training it further. And here's what the actual performance of that model looks like. Much better, right? So it's exciting to see that the model can actually classify these different objects, of course, based on what we taught it. But, a construction project doesn't just have a small, a medium, and large and metal objects. So we had to actually test it with real elements from a typical construction project. So what we did is we drove to the nearest Home Depot and bought metal conduit, we bought a PVC pipe, and we bought an actual segment of a metal duct in order to test this AI model and actually also use some of these elements to train it. And here's what the actual confusion matrix of the model that we did for classification purposes. Again, this is all phase one. It's classifying, is like, what is the element between the transmitter and the receiver? As you can see, it's doing pretty well. So metal duct, no problem, 96% accuracy. I will tell you that's a metal duct. I don't have a problem with that. But when it comes to a small conduit, it starts to get a little bit tricky. It sees it's 74% accuracy, but at the same time, it also confuses it with it being empty. So there's still a little bit more work here in terms of trying to teach an AI model all these different variations of the different elements that would go in a construction project. So that was phase one. Phase one is just classifying, just trying to understand what the object between the transmitter and receiver are. Phase 2 now is localization. I'm trying to understand where this object is in this specific space. As we mentioned earlier, right? When you put in transmitter and receiver nodes, that's what we're thinking about, a vision for the product. You have to assign them an area, specific location, right? Because you want to localize within that specific location. You don't want to localize overall on a global aspect. So phase 2, we did it in 2 different ways, right? So we had a room that has a transmitter and receiver, and we designated, is it on the left, is it on the right, or is it in the middle of the room? And we did different configuration of the antennas of those Wi-Fi routers themselves. So, and I'll talk about that in a minute, which is like we found out like the more you spread out those antennas from each node, the more information you get that you can actually localize much more accurately. So here's what we did. We took the classification that we did in the previous phase, but instead of using the 0.5 and the metal conduits because they were still confusing the AI, we said, let's stick with the PVC pipe and the air duct, a big metal duct, and see if we can localize those, right? And here's the confusion matrix of the localization. As you can see, it's really getting much, much better reading on if the object is in the left side, if it's in the middle, if it's in the right side of that specific room. So that's exciting. But again, when we did the different configuration, as you saw, this is what we call multiple in, multiple out, because in phase 1, when we did it, we had only one antenna for the receiver, one antenna for the transmitter. But for the localization, we recognized that we needed more antennas for each node. So now we have 2 antennas each, but the more you spread those antennas out within the unit itself, the more accurate readings you get. You can see like how like antennas closer together, you can get some dispersed readings where when you have them separate, a little bit apart, you get a much, much better reading in that kind of consistent diagonal again in the confusion matrix from the top left to the bottom right. So we're getting super excited about ProjectWise and what it can do for construction projects. And what we've been doing so far, it's nothing really revolutionary. We're not trying to reinvent the wheel. We're not trying to recreate a Wi-Fi router from scratch and figure out how to make it more optimal. We're actually using stuff off the shelf. This is what it looks like. This is the unit that we actually use to test and train the AI model on. And what it is, it's a very simple Raspberry Pi with an additional Wi-Fi chip installed on top of it. And again, these are very small units that right now they require even like be plugged in. We did a module where it has a small battery in it, but it's nothing that I'm ready to take to a construction project yet. As I'm saying, this is still a research and development project. And we're working diligently in looking at enhancing the AI model, looking at even going to maybe we need at some point to get to, let's see what a Wi-Fi node would look like, right? Let's think of it from the ground up and create something that's very specific to ProjectWise instead of using off-the-shelf products. We're not there yet, but we're taking it one step at a time. So, and kind of conclusion, ProjectWise will enable a near real-time progress tracking of construction projects. Now, why do I say near real-time? Because my lawyers tell me to never say real-time. Real-time is very tricky because you have that it's very quick. It's like this. It's like immediate. As soon as you do something, you get it. Where near real-time, the way that we're envisioning WISE to function is installing all those nodes, which would collect data on specific timeframes. So you would say after the end of the shift every day, capture that and put it in the dashboard so somebody can go into a web browser, log in and see what the actual progress is as of the end of yesterday, for example. We're also thinking adding maybe a button that says capture that right now, right? But there will still be some latency and some lag between capturing that and actually giving it to the end user. That's why we're saying near real time. Guaranteed, this is going to be much faster than your photos, videos, than your 360 image captures, than your laser scanning an entire job site. So near real-time progress tracking that's accurate, and that's also going to have an additional layer to it of early detection of potential issues. So as we talked about the localization aspect, and we also talked about comparing everything that the AI model thinks it sees to a 3D model, what if we're detecting that, yes, there was a duct that was installed in 3rd floor, section C, but it looks like it's in the middle of the room where my model shows it in the right side of the room. There's some discrepancies here. And we're thinking about maybe flagging that out to the project manager or superintendent, saying, hey, maybe there's something that you need to check here, or I don't have the latest information or the latest model. Maybe something has changed in the design phase. So again, this will help us, a construction projects that are in progress, to capture progress very accurately, very timely, and to raise any potential issues of installation deviations. And what that would lead to is ultimately faster payment applications processing. And it gets everybody on the job site moving, because as we all know, cash flow is king, right? Cash is king, and everybody needs to get paid in order to pay the next person. And if we don't have those measures, that what always hinders processing any payment applications, because payment application says we finished 50% of HVAC scope. Let me go check it. Let me go kind of verify that before I process it. And that's kind of what we think WISE will help with that aspect. So this is, again, WISE in a nutshell. I would have loved to be there with you all and see the reaction as I'm presenting this, with all my jokes that I was throwing out there and all the back and forth. Unfortunately, that's not happening today. But I would love to hear your feedback. I would love to hear your questions, your comments. And more importantly, I would love your insights. We are actually in a phase right now where we're stopping development for a second in order to get all these market analysis and kind of like go-to-market strategy for such a product. So I would love to talk to all of you, or as many of you as we possibly can fit in. We can schedule a 30-minute call just to kind of pick your brains and understand what you think of this approach, or what you think the problem statement actually is. If you don't agree with what I'm presenting, please let me know. I would love to have that conversation and see how we can move the industry forward to a brighter future. Thank you all so much. And again, I'm super bummed for not being there with you all and partying and enjoying this amazing conference. I've been trying to get there for the past 3 years now, but as luck would have it, I still cannot make it to Boise, Idaho. If you can't scan the QR code, or if you don't want to kind of put your information in there, just shoot me an email, hamzah.shanbari@haskell.com, or I'm always on LinkedIn. So if you look up, search Hamzah Shanbari, love to connect with all of you and have that conversation and talk about WISE. If you want more information, the website is coming. I was hoping that it'll be live today. Fortunately, developers still working on it, but it'll be ready next week. Is wisebuild.ai. But we do have the intake form there, so please go and fill it. Let us know you're interested in looking at the project itself and helping us with insights. But also, if you're interested in deploying this in your future job site, we'd love to learn more from you and get all that insights. Thank you all so much for bearing with me. Thank you, Matt and the team, RCN, for putting up with us and our storms here in stormy Florida. And I hope to hear from all of you soon and hear the feedback too. If you want to post about this on LinkedIn, please just tag me and let's see the conversation going. I have 5 minutes, scheduled or put in for questions, but unfortunately I'm not going to be there. But if you shoot me those emails or that on LinkedIn, I'd be more than happy to respond to each and every one of you. Thank you.